All right, we're looking at 3.4. The goal here at 3.4 is to read values of an inverse function from a graph or a table. Well, now we really need to understand what in the heck is this inverse function business. All right, so an inverse function, and there's so much to be said about the word inverse. Just know that it's an adjective, it describes a noun. All right, so an inverse function, this simply is an inverse function. It switches inputs and outputs. That's as simple as I could possibly put it. So x values become y values become x values. So we take x's and y's and we switch them. All right. So we're gonna take a look at how that is in a little bit. But I want to show you the notation here. So for an inverse function, we're gonna write it like this. We're gonna say f inverse of x. Right? And then we say this as f inverse of x. So this isn't f to the negative 1 power, nothing like that. Right? This is f inverse of x. Okay? Now, this takes an original f of x and makes the x's y's and the y's x's. So, again, I cannot emphasize enough what exactly is happening here. We are switching the x and the y values. So let's take a look. If I had a random chart of values, so let's see if we have an x and an f of x. Let's see, we have like -6, -4, -2, 0. Let's go 2 and 4. And I don't know, 17, negative 1, 12, 3, -5, and 11. Right? Okay. All right. So let's say, for example, this was given to us, and we wanted to know f of, let's go -4, right? Just f of -4. Well, this is the regular function. Note, it's a regular function. So when x equals -4, f of -4 would equal -1, right? And if we want to know like f of 2, well, when I plug a 2 in for x, -5 comes out for y, right? And we're used to this. We saw this just not very long ago. Well, f of 0 is 3. Now, when we're dealing with our inverse function, f inverse of x, right? Remember, this is going to switch x and y. So if I say f inverse of 11, well, now I'm looking for the y value of 11, and the output then equals a 4. Right? It used to be that this was the output. When I plug in a 4, I get an 11 out. But when we say the inverse, now note, when we say inverse, then these become my inputs and these become my outputs whenever I'm dealing with f inverse. Right? These become my outputs and these are my inputs when I'm dealing with f inverse. So if I said f inverse of 3, we plug a 3 in, we would get a 0 back out. All right, let's take a look at a couple more examples. I'm going to do one more table, and then we're going to take a look at what happens on a graph. So let's do this guy here. We have inputs and outputs. F of -3, well, -3 produces a 6. This is a regular, right? There's no inverse yet. When I plug a 10 in, what do I get out? So 10 goes in, -7 comes out. And when a 6 goes in, a 2 comes out. Now we got to switch our thinking. Switch. Where my outputs are now my inputs. So these are my inputs and these are my outputs. So when I plug in a 6 to the inverse function, well, here's 6 on the inverse, a -3 pops out. When I plug a 7 in, or excuse me, a -7, -7's here, a 10 pops out. So we get a 10. Right? These are my inputs, these are my outputs. I plug a 4 in, 4, a 21 comes out of the inverse. Now, what does that look like on a graph? All right. So, here we are with a graph. And these first two are regular, right? There's no inverse symbol. All right, so this is f of 1. All right, so when x equals 1, my y value is a 1. And when x equals 4, my y value is a 2. Okay. I'm with you so far, Stevens. Now, what about f inverse of -3? So now, for these next three, you got to think switch. I got to switch them around. So the inverse of -3, well, I go to well, there is no -3 on the y-axis, so this does not exist. All right, so what happens about f inverse of 2? All right, so f inverse of 2, I'm looking at my y value of 2. When my y value is a 2, my x value is a 4. And then finally, let's go f inverse of 3. All right, so on the y-axis, where's 3? Here he is. And it hits this point right here. And my x value that comes out is a 9. So when 3 goes into the inverse, a 9 comes out.